Welcome to episode 9 of the Physiology 225 podcast. I'm your host, Dr. Jim Davis, and I'm thrilled to have you join me as we dive into the fascinating world of the nervous system. This episode will cover the primary functions of the nervous system and introduce you to some key concepts that will form the foundation for future episodes. Next time, we'll take a closer look at graded potentials, but for now, let's start with the big picture. It's important to remember that the nervous system is your body's ultimate control center. It coordinates everything from sensing your environments to initiating movement. Its primary functions can be divided into 3 categories. First, we have sensory function. The nervous system receives information about your environment, both internal and external. For example, sensory neurons detect changes like temperature or pain and send this information to the central nervous system via afferent pathways. Once the information reaches the central nervous system, it is processed and interpreted. This integration function helps your body decide how to respond to stimuli. Interneurons play a significant role in this process by relaying information within the central nervous system. After processing, the nervous system responds by sending signals via efferent pathways to muscles or glands, initiating actions like movement or secretion. These signals are carried by motor neurons, and this function is referred to often as motor function. You can think of the nervous system as a control system that manages the behavior of other systems in your body. Using feedback loops, the nervous system regulates activities to maintain homeostasis. This is similar to the concept of feedback loops we discussed in earlier episodes, but now applies specifically to neural pathways. Understanding the types of neurons involved in the nervous system pathway can clarify how it all works. You have afferent neurons, interneurons, and efferent neurons. Afferent neurons are sensory neurons that carry information towards the central nervous system. Interneurons are found within the central nervous system where they process, integrate, and relay information. And then finally, efferent neurons are motor neurons that carry signals away from the central nervous system to effectors such as muscles or glands. Now, neurons rely on ion channels and electrochemical gradients to carry out their functions. And so here's a basic overview. First, you have leak channels. These passive channels open and close randomly, allowing ions like potassium and sodium to move across the membrane. They establish the resting membrane potential. They're referred to as passive ion channels because they don't need a specific stimulus to cause them to open. Then there are voltage-gated channels. These channels are found primarily on axons and open in response to changes in membrane potential, allowing ions to move and propagate action potentials. Ligand-gated channels are located mainly on dendrites. These channels open when a specific chemical, called a ligand, and an example of this would be a neurotransmitter, binds to them. And then finally, it's important to know about electrochemical gradients. When ions move, their movement is driven by both concentration gradients, so going from high to low, and electrical gradients, meaning opposite charges are attracted. Together, these forces create the electrochemical gradient, which determines the direction and flow of ions. The flow will always favor the direction of the larger gradient. For example, even if sodium ions are drawn inside by the electrical gradient, they may move out if the concentration gradient is larger. The electrochemical gradient reflects the combined influence of these forces and is critical in driving neuronal activity. So let's summarize with 4 key takeaways. The nervous system has 3 main functions: sensory or input, integration or processing, and motor or output. Afferent neurons bring information to the central nervous system, interneurons process it, and efferent neurons carry out the response. Ion channels and electrochemical gradients are critical for neuronal function, enabling signal transmission and communication. Electrochemical gradients direct ion flow based on the strongest driving force, whether it's concentration or electrical. So that's it for episode 9. I hope this introduction to the nervous system has laid the groundwork for understanding its complex and fascinating functions. In our next episode, we'll dive into graded potentials and explore how they play a role in neuronal communication. Until then, keep questioning, keep exploring, and stay curious.